Okay, so here's a couple where we're putting everything together. So especially that now we have all 5 transformations, I would recommend every time off to the side, put a reflection, period, amplitude, vertical shift, phase shift. This way we can work through everything that's in the problem. So first, reflection. There's a negative being multiplied outside that sine graph. So yes, there's going to be a reflection. And what that means for sine is it still starts in the middle, but this time it'll go down before it goes up. So the reflection just affects the shape. Next, look for our period. So the period of the graph is affected by anything being multiplied by theta. So what we do, we take 360, divide by whatever is being multiplied by theta, type that in a calculator, and get that our new period of the graph is 120 degrees. Next, the amplitude. The amplitude is affected by anything being multiplied outside the sine function. So this time sine is being multiplied by 2, so our amplitude will be 2. Next, the vertical shift. That is affected by anything being added or subtracted outside the function. So in this case, there's that plus 4 outside the function. So our vertical shift is a plus 4, which means we are moving up 4 units. Lastly, phase shift would be anything being added or subtracted inside the function, meaning inside the parentheses. Since there isn't anything being added or subtracted, there just isn't one to worry about. So to graph it, draw our axes. Since there's no phase shift, we know this one is still going to start at 0 degrees. And then to figure out where it's ending, remember you just add your period. So in this case, 120 degrees. That means we're going to end at 120. And 0 plus 120 is 120. Now we need to divide it up, get our labels of that graph on. So we're dividing into fourths. So if off to the side, you just want to jot down, okay, 120 divided by 4 is 30 degrees. So that means every tick mark is going to move 30 degrees. So 30, 60, 90, and yes, if you add another 30, you'd end up on 120. Now bring back all the vertical stuff from before. Our vertical shift is up 4. So that means the middle of our graph, 1, 2, 3, 4, will be up here at 4. And then our amplitude is 2. So that means the top of our graph will be 2 above the middle. 4 plus 2 is 6. The bottom of our graph, 4 minus 2 is 2. Now we have our whole layout. It's just a matter of graphing the function. So we're doing a negative sine graph because it's reflected. Our sine starts in the middle regardless. So now our new middle is 0, 4. And then since it's reflected, it'll go down for that first tick mark. So you should have a point at 30 degrees 2. Back up to the middle, up to the top, down to the middle. Connect all your dots. Put arrows on the end to show that it's going to keep going on forever. And there you have your graph. Okay, one more with a bunch of transformations. So again, write everything out to start. So reflection, amplitude, period, vertical shift, phase shift. Doesn't matter what order you're looking for them in, just remember that there are 5 altogether. So first thing to check is for reflection. For reflection, you check either on the theta, there is nothing there, or we are checking before the cosine function. That's positive. So since it is positive in both those spots, no reflection to worry about. Amplitude. Again, you are checking right before the cosine function for the amplitude. There's not actually a number written there for this one, which means it's just a 1, so the amplitude of this graph is going to be a 1. For the period, we are doing 360 divided by whatever number is multiplying inside the function. So yes, this 1/3 is kind of factored out this time, but keep in mind it is still multiplying by that theta. So we have to do 360 divided by 1/3, which really turns into 360 times 3. So the period for this function is going to be 1080. Next, a vertical shift. A vertical shift is adding and subtracting outside the cosine function. So in this case, we have a 3 plus cosine. So vertical shift is a positive 3, which means we are moving up 3. And lastly, our phase shift is anything being added or subtracted inside the parentheses. And you will see a lot of these problems with the double parentheses. It is just giving it to you in a form where you can take the phase shift directly out of the function. So phase shift, it says plus 540. Remember, for phase shift, you have to do the opposite. So if it's a plus 540, really that means we are moving negative 540, so left 540 degrees. So now let's just put all of that together. So we draw out our graph. We know we are starting left 540 degrees. It's going to be over here somewhere. So our start is going to be at negative 540. We know our end is going to be 1080 degrees beyond that. So if we type in the calculator negative 540 plus 1080, we get that this is going to end at a positive 540 degrees. So 540 is our end, negative 540 is our beginning. We have to divide that up into 4 spots. So in this case, you're going to figure out kind of how far each tick mark goes off to the side. Write off to yourself our period's 1080. To divide that into fourths, we get 270. So that means every tick mark is going to move 270 degrees. Negative 540 plus 270 is a negative 270. Plus another 270 is 0. Plus another 270 is 270. Plus another one is 540. So we have those labels. Now we need our vertical labels. Our vertical shift is up 3. That means the new middle of our graph is up here at 3. Our amplitude is 1, so that means the top of our graph is going to be at 4. The bottom of our graph is going to be at 2. So now we just put it all together. We are graphing cosine, so we go to the beginning over here where our start is. We know cosine starts at the top, so we're going to have a point at negative 544. Then we go to the middle, bottom, middle, top. Now we should have 5 exact points on every graph. Connect them, put those arrows on to show it goes on forever, and you are done.